Sai, water bottle. हाँ सर.
वो सर एक नया रिसर्च प्रोजेक्ट yes.
सर एक डिटेल तो बाकी है एंटर करने के लिए सर का.
Okay, so we recap a little and then we move on, right? This system is quite good. Let's worry about it. Quickly we'll recap everything. So we started with feedback. Why is feedback required? Then we saw multiple reasons. And what can go wrong with feedback? What can go wrong in a feedback system? Like this system, feedback, what can go wrong? So what do we have to be careful? So feedback, high gain. We saw that by having a high by having a high gain, we get lot of interesting properties. But what is it we have to be careful about? जहाँ feedback लगाते हैं. नहीं नहीं ऐसी बात नहीं है. पर उसकी बड़ी प्रॉब्लम बताएं. ये तो छोटी प्रॉब्लम. तो क्या what larger thing we look at whenever we have feedback? The larger issue. The larger issue we look at is instability. Right? Is that the larger issue or not? Instability due to feedback. And to make sure that or to ensure stability, what do we need? I am designing a feedback system. I know that high gain will help me in several ways, but high gain will also cause instability. So when that happens, what is it I need? What I need is system model. If I have got a system model, I have got ways to prevent the closed loop system from going unstable. And we had a look about system model. We discussed what type of model was very convenient for us. We had a look that we'll model these systems, and we discussed one particular type of model, right? That we could obtain it by doing measurements. कौन सा मॉडल था वो? Yes, loudly? Frequency response. Right? So these are the logical steps. You can have many different types of models, but these are logical steps. Feedback, instability, system model, frequency response, and then we briefly looked at these two things. System uncertainty or modeling uncertainty and disturbance. If these two are not there, we don't need feedback. We can do open loop control. because of these two things, we had all the issues. Right? So, this is where we are, that these are essential, some ways to think and design. And believe it or not, this instability is everywhere. In every algorithm can become unstable. Right? When you are doing numerical solution, it can become unstable, and that you have to be careful about. Okay? So these concepts are quite general. Although frequency response is limited to linear system, but most of the systems we can linearize with small changes, etc., etc. So remember this. You know, when I was little, I used to go with my nani to hear a kathakar. So he gave Katha, Mahabharata, Ramayana. I remember every night I used to go. So there is a technical term, drishtant. I don't know whether it's there or technical term, drishtant. So he used to illustrate. So he said there were two thieves, and they had made a resolution that they are never going to hear a kathakar, never going to be involved in anything related to God. So एक जगह कथा चल रही थी, and they had to cross, so they did like that, so that they didn't have to hear. पर वो मच्छर आया, तो हाथ उसने ऐसा किया, तो तब कथाकार कह रहा था कि भूत के कभी परछाई नहीं होती, there is no shadow of a ghost. So that's all right. So one day they were going, and they were accosted by a ghost. उसने कहा मैं भूत हूँ, पैसे दे दो, तो डर गए, घबरा गए. Then they saw a shadow. यार उस कथाकार ने कहा था शेडो तो नहीं हो सकती. So they said, किस बात के भूत हो you, because you got a shadow. So what I'm trying to say is that by mistake also, what you hear can be of use to you someday. So what I'm saying this, because I'm very, very confident that these steps are very fundamental to our way of thinking. So that's why I keep repeating, and maybe one day this might come back to you when you need it. Okay? So that's how we are now. So this is sort of our recapitulation of what we did before. Now let's come to this. I will come to some details about machine learning, which I think are quite important. Small little things like what we did here, small little things. But before that, let's set up a scene. So Professor Kulkarni said that some of our participants are interested in hosting capacity evaluation, right? So this is a vast field. My students have been involved in these projects to get hosting capacity evaluation, millions of dollars. But what is the intellectual content there? See, we are in a university, so we are not so keen on the work which is needed, but we are keen on the intellectual content that is required for hosting capacity. Now, just earlier we were talking about Makaranji and Professor Kulkarni, and I shared that as a researcher, focusing on planning is not a good idea. Doing research which involves planning is not a good idea, because nobody is going to listen to you. You know, Gadkari went with 100 crore rupees to IIT Madras people for road thing. They are not going to come to you. Nobody is going to come to you for planning job. So all you want to do your research in planning, that's always a very risky business. You should do research which is operational real time. And then nobody can match you. You have an algorithm for a particular situation, you run with that algorithm, you improve that algorithm, and that is, your research will be fruitful. Right? So most of the times I try to focus on things which are we need in real time, not just planning. Planning is a minefield. I mean, who cares about what you think? You think ministers are going to care about what you think? Chairmen of the these electricity boards are going to care about what you think? They don't care. They have got these big people, big consultancy company, they will go to them and get even wrong or right, whatever it is. But that report they can say, oh, I got it from Deolite or whatever. You know. So planning is, and I have seen our students get involved with planning and they produce those reports. मेरे को लगता है यार इसमें क्या मतलब है इसका? $1 million gone because they have done hundreds and hundreds of studies. उसका क्या? Intellectually I don't see much value. I can see because you have to put in some work, etc. So please keep that in mind when you are trying to pick up a research area. Unless somebody has given you money, like Gadkari Saab came and said that, okay, here is 100 crore for the roads. That's all right, then you have to do it. But if doing planning on your own is a hazardous business. So, let's come to hosting capacity and what is needed in real time. Right, hosting capacity, PV hosting capacity or EV, it is same, the methods are similar. So what do we need is every instant, we need to know how much PV can the system absorb and what can go wrong, right? So if you have got less PV or if you have got more PV, less PV का तो अभी वहाँ problem नहीं है because all the fossil fuel generators are working in Australia. यहाँ भी आपके बड़े nuclear वगैरह सब काम कर रहे हैं. So less का it is not that big an issue. Very soon the issue will be when it is more, right? So anyway, our analysis we can do both of them. So hosting capacity, what is the basic tool for hosting capacity? What is the basic tool you need to do this analysis? So if I say that it can host, say, 100 megawatt, if I can say. So what is it I have to make sure? If I can say 100 people can sit in this class, I have to make sure that there are 100 chairs, right? So if I say that 100 megawatt is the hosting capacity of this system, what are the things I have to guarantee? Yes? Pardon?
Load of 100 megawatt.
Okay, very good, very good, very good. Thanks. Enough load, very good. That's a very important point. Thanks. Very important point.
In fact, more than that, because the thermal power stations will be running at
Correct, correct.
30%.
Yes. Wait. Sorry about that. क्या करें? हमारे यहाँ पे रिकॉर्डिंग कंपलसरी है. हमारे यहाँ lectures when I give recording is compulsory. We have to because students who can't attend and all that. तो मैं हमेशा कहता हूँ I pity that unfortunate student who has to listen to this recording. अब कितना वो होगा? I mean, how boring it can be, I can't imagine. But anyway, so load, appropriate load. If I say that, will that be all right, sir? Appropriate load requirement? That's good. Thank you. Anything else you have to verify? See, आप कह रहे हैं you are a consultancy firm. आपका उसने बॉस ने फोन किया इलेक्ट्रिसिटी कंपनी के कि प्लीज टेल मी व्हाट इज द hosting capacity. You say 100 megawatts, but before having done that, what have you verified? What have you checked?
Cable ratings.
Cable rating. So if I can say currents within limits. Yes, good. What else? Yeah.
What duration that would be? Are we considering storage?
Okay, how do I put it? How do we put it? Okay, so time. Okay? Time profile. Okay? Will that do? Will that do? Time profile. Right? कि 8 बजे 100 होगा, तब 80 होगा. You want a time profile. That's good. Good. When I give 100 megawatts, I should also give time profile. That's very good. Anything else? I have to make sure. Something similar to this. What else I have to make sure for a operation of power system? What is the most fundamental thing we check day and night? लॉसेस तो ये कम होने चाहिए, पर वो अपन उसकी चिंता नहीं करते. व्हाट वी चेक इज वोल्टेज प्रोफाइल. That is the biggest obsession, right? The voltage profile is right or not. Because that's, as sir will tell you, it is a regulatory requirement. But other than regulatory requirement, it tells us whether our generation and load is meshed, whether we are doing things in the right way. It is regulatory requirement because it tells us the health of the system. Okay, the rules are not made arbitrarily. So these are the few things we have to think. Okay. What sort of analysis we need for appropriate load? Consumption pattern, so forecast, right? Forecast. English language, it is not under the control of English people anymore. Forecast, broadcast, इसमें कोई continuous test, वो एक ही word था. Forecasted, forecasting, broadcasted, एक ही word था. Every tense, only one word used to be used. Now इतने non-English speakers हैं इस दुनिया में कि forecasting has become a standard. So I feel sorry for the English people. So forecast algorithms, right? So we need forecasting algorithm or forecast algorithm. So current within limit, time profile, the same story, right? So we need somebody external to tell us these things. So they look at the solar radiance and say that this will be the available capacity, and somebody else says this will be the load capacity, so we hire 2 people to do that. And these 2 things are related, or still we have to hire 2 different people to do that? Finding current limit and voltage profile. Are they related the same way as, are they separate? Like we have to hire one person to do this, another to do that, because load and sun may not be related. So किसी को कहा कि तुम sun का बता दो, किसी को कहा तुम load का बता दो. Then we have to integrate it with our thing. So whom do we approach to get this thing? So if we can't get this thing reliably, our this hosting capacity estimate will never be good. Right? So how do we, what is the type of analysis we need to pardon? Power quality तो बहुत वो term it is, power quality falls out of it if you like. So, okay, power quality mostly people mean harmonics, right?
Analyze use all parameters.
हाँ, analyze. तो अपने को तो हाथ से करना, measurement तो नहीं करना अभी, because we have to do all the work. So क्या ऐसा है? What is it we know, or we do it? People do it thousands of times every second. कंटिन्यूसली चल रहा है वो काम. कौन सा वो मेथड है और कौन सा वो प्रोसेस है? Right, you have to do a load flow analysis, which is done repeatedly, millions of times. Right? Now, before we go, we have to understand this well, because all the work we have done is based on understanding of this system, this thing. Or regardless, you have to know this power flow. So how many of you have written programs to do power flow. Maybe 2 bus, 3 bus. लिखे आपने? नहीं लिखे? ये बहुत जीवन में एक बार करना बहुत जरूरी है. वो हेट एंड कैमर्ली की किताब तो यू नो राइट, सर्किट थ्योरी, हेट एंड कैमर्ली, राइट? So their convolution, we all know what is convolution, right? So there is a proof for convolution, and he puts a footnote, or they put a footnote, that only politicians and second-hand car salesmen can afford not to do this proof. कुछ चीजें इतनी इंपॉर्टेंट होती हैं कि यू हैव टू डू इट योरसेल्फ. सो लोड फ्लो भी इतना इंपॉर्टेंट चीज है कि यू हैव टू डू एटलीस्ट 3 buses द मिनिमम. You can do it very easily. I mean, the first time I taught in Australia. So we all use computer programs to do this load flow, right? So there was a student, and I have never had a student like that before. That was my first time teaching. So load flow, मैंने दिया problem. So he had an answer using computer program. और फिर मैंने देखा दूसरा, he worked out by hand. मैंने कहा यार ये क्या? Well, I always do every problem 2 ways to check the answer. But वो बहुत बड़ा ऑफिसर बना, बहुत बड़ा ऑस्ट्रेलियन डिफेंस फोर्स में. He went very very high. So I had that student who did load flow by hand, and I did. It was not 3 bus, it was 4 or 5 bus. So सारा उसने hand से किया. So I remember even I have not done that. I have only done 3 bus by hand, the rest by computer. Okay. So that's just a story. I can't forget that. So what is load flow? We have to have a good understanding of what is load flow before, and that is needed. And it's not a very complicated thing. It's a very simple thing. So what is load flow? What does load flow give us? ये बहुत important question. What does load flow give us? क्या वो हमको देता है? So what are we looking for here? What do we expect to get out of load flow? Voltage profile, right? Thank you, madam. Voltage profile. Good. What is it? What do we know from our background that gives us voltages? See, we have to connect what you already know. So वो क्या चीज है? अगर हमको किसी चीज का वोल्टेज प्रोफाइल लेनी है किसी सर्किट का, तो क्या करते हैं हम? What do we do? What tool do we use? Yes, sir. Yeah. KVL and KCL. मैंने आपको प्रॉम्प्ट नहीं किया, पर ये पेन एक पाकिस्तानी स्टूडेंट था, अंडर ग्रेजुएट. तो मैं जब पढ़ाता हूँ, आई टॉट इलेक्ट्रॉनिक्स टू देम. सो ऑल यू नीड टू नो आर 2 इक्वेशंस. मैं बार बार बोलता हूँ तुमको और कुछ जानने की जरूरत नहीं है. जस्ट नो हाउ टू राइट दीज 2 इक्वेशंस और सारी चीज आपके जेब में है. सो ही गॉट अ पेन मेड लाइक दैट, गिव इट टू ऑल द एंटायर क्लास. सो आपने भी यू जस्ट named those 2 equations, which I think is all you need to know. Okay? आपको इससे ज़्यादा कुछ नहीं जानना. Right? So KVL, so let's complete the story. So KVL we used to find what? What is unknown when we write KVL? Loop current. Very good, sir. And what is unknown when we write KCL? Very good, sir. ये यूपीएससी आ रहा धड़ाधड़. एक बार चालू किया तो फिर रुकेगा नहीं वो. Very good, sir. So KCL we have identified. as the tool we have. Now, आपने सबने KCL करा in your undergraduate thing and all that. So why do we call it power flow and not just KCL? KCL भी कह सकते हैं. Why do we give it another name? That is very important point. Why do we give it another name? वो KCL ही है. आपने एकदम था KCL ही है. There is nothing other than KCL.
Because power system is very complicated network where number of buses are there.
Yeah.
Difficult to analyze by KCL.
क्यों नहीं? Oh, there is nothing else other than that. आपको ट्रैफिक रोड पे कितना भी ट्रैफिक हो आपको जाना तो रोड से ही है. There is nothing other than KCL. No matter how complicated it is. It's only KCL and KCL. So it's important to know any. Very good sir. आप उसको एकदम पूरा बताएं अच्छी तरह से. Current is representing load का क्या मतलब है?
Whatever is load demand, that is actually reflected in the form of current first, and then it is going to affect the voltages.
Very good sir. So क्या अंतर है जो आपने अंडरग्रेजुएट में किया था और जो आप पढ़ाते हो and what you are just saying? What is the difference? What you said is right, but अंतर क्या है? अंडरग्रेजुएट में भी खूब करते हैं KCL वगैरह. So what you are saying and what is the difference there? Because that analysis is very simple. KCL, matrix inversion and you are home. ये थोड़ा फिडली है. इसमें तो लाखों डॉलर इसमें लगे हुए हैं, करोड़ों रुपए इसमें लगे हुए हैं लोड फ्लो में. क्या आपने कहा वो सही है, एकदम सही है. But what is the difference? Can anybody identify the difference? Because what sir is saying is that a load is specified in terms of the current it will draw. यही आप कह रहे हो ना. और बाकी में जो होता है अपन एनालिसिस करते हैं वहां लोड कैसे मॉडल करते हैं जो आपने किया है. सो आपने अंडर ग्रेजुएट में जो KCL लिखे हैं वहां लोड कैसे, क्या मॉडल था लोड का? वेरी गुड. तो उसका टेक्निकल नाम कांस्टेंट इंपीडेंस. I'm just saying it in a different way. आपने कहा constant current, मैंने constant power कह दिया. Right? So it could be constant power, constant current also, etc., etc. So there are few ways you can represent, and most of these load flow programs, commercial ones, will let you represent it in one of these ways. ये लगने से क्या मुश्किल हो जाती है? आपने कांस्टेंट इंपीडेंस एज यू सेड वी रिप्लेस इट विद कांस्टेंट पावर. तो क्या ऐसी बड़ी मुसीबत आ गई? कोई मुसीबत आ गई इसमें? पार्डन? या वो तो सब जगह होता है. मतलब क्या एनालिसिस में क्या मुश्किल आ गई जो अपने को अलग एनालिसिस करना पड़ रहा है? So you all teach, you know that खटखट मैट्रिक्स इन्वर्ट किया और you get the load voltages, right? उसमें कुछ है ही नहीं KCL में तो. But why we have to take extra trouble to do it with load flow? So the story is this. Constant impedance load, V on I is constant, and there V I star is constant. So that makes it non-linear. So your analysis is non-linear. And because it is non-linear, we don't have analytical solution. We have to solve non-linear algebraic equations simultaneous. If there are 1,000 nodes, 10,000 nodes, so we have got one KCL for each node, and then we do this, that. Okay? Now, what do we do? What do we do? So, ये तो overall picture हो गई. Okay, so let's, one more thing I wish to say here. What type of analysis is load flow? That's an important one. What type of analysis is load flow? Yes, sir? Steady state. It is sinusoidal steady state. It says that all the transients have disappeared. This is a mega assumption. And because of this assumption, we can do so much in our power system analysis, because with this assumption, so as soon as we say sinusoidal steady state, what comes to your mind? Why does it make our analysis simple? ये सबसे पहले दिमाग में आना चाहिए. Phasor analysis. And because phasor analysis, why is phasor analysis easy? Because it is algebraic equation. If it is differential equation, then it's a very difficult situation, right? Because you could take transients and all that. So we always do sinusoidal steady state. So we assume that no matter what transients occur, so when you integrate dynamics with load flow, we assume that no matter what transients occur, in 10 milliseconds they will die down. I mean, it's up to you to accept that assumption or not. जैसे कहीं voltage बदला, in one of the stations the voltage changed. We assume that in 10 milliseconds it will achieve steady state. The transients will die in 10 milliseconds or 5 milliseconds or something like that. So that is one very big assumption. कभी जिंदगी में मौका मिले और तो सोचना उसके बारे में, or maybe one day will come when that is not valid. See, in distribution systems, it seems it's not as much valid as in transmission systems. So many distribution systems, like if you have Power Factory, right? You would have heard the name of that software, Power Factory. Yeah. So they have got a distribution system analysis where they don't model the network in sinusoidal steady state. So there are many analyses we do not. So you have to know when we can do and when we cannot do. Okay. So now, with this story, do we need to see the equations? Unfortunately, we pass. Okay. I'll think about it. Do we need to? So maybe I can find. I have got a lot of notes where you can see the equations, what the equations look like, and why we need this. Now, what has it got to do with hosting capacity? So when we say 100 megawatt is all right, we have to make sure that voltage profile and currents. So once you know the node voltages, currents are like that, right? Node voltage is divided by impedance is the current. So once you know the node voltages, current is just given to you. And you make sure that this is right, etc., etc. To do that, you have to do a load flow, right? And to do it well, you have to do multiple load flows. Can you tell me, if I want to say that 100 megawatt is the hosting capacity, why do you think I need to do multiple load flows? Just one will not do. I want to say that 100 megawatts is the hosting capacity. Then why I have to do multiple load flows and guarantee that in each of those load flows, my voltage profile is preserved, the currents through the cables are within safe limits. Okay, so what hosting capacity things I know, many times this current is a problem, limitation, that voltages are alright but currents are very high and it's unsafe. So both the things, if I make sure, why do I have to make sure for multiple cases? आपको machine learning hosting capacity सीखना है, तो you have to appreciate that point. If that point was not there, we don't need machine learning. Why do we need multiple load flow analysis to tell the boss that yes, 100 megawatts is all right? ये बेसिक पावर सिस्टम ऑपरेशन का वो काम है. That is what people who do in power system or power companies who are working in analysis, that's what they do. They do these things multiple times. So why do they have to do multiple times? वो तो है ही, पर multiple times क्यों? जैसे लोड फ्लो क्यों हजारों बार करना पड़ता है? What are the things which change? It's a power system, dynamic system. What are the things that are changing? Load is changing and phase angle तो आपने अच्छा पकड़ा phase angle. Load is changing. Phase angle, yeah, you are right, phase angle, because unless you change the phase angle, you can't change the power you push, right? So that is changing. So load is changing 100%. And we do not know, हर घर का load we do not know accurately. So, or whatever it is. So we have to have a probability distribution or something like that, that these are the 10 different load patterns they have. Okay, and the sun thing, and the PV is in so many houses, and many times we don't know किस घर में PV है. So we model. So we have very large combination of generation and load to take care. We cannot just say that this case I have done it, and that's it. No, you have to have hundreds of cases. And that's where machine learning helps us. That's what at least we did it. Okay? So hosting capacity के साथ बहुत झंझट है. सबसे बड़ा झंझट ये है कि what is the definition of hosting capacity? Right? क्या definition है? The one we use is that we have got 100 megawatts. So there are hosting capacity algorithms which have 100 megawatt, but they put all 100 megawatts on a single bus and do the analysis. और कुछ का divide है, कुछ का ये है. There are many different ways they do hosting capacity. What we have been doing is, if we have got 100 megawatt load, we use Monte Carlo or some sort of simple technique to distribute it over the network. And once we distribute, we do then another distribution we do, then another distribution we do. So multiple distributions of load and generation we use to do the analysis. Now, okay, is that convincing? That we have to do it multiple times. And if we can save, okay, so multiple times is clear. So I'll go to the next step now, that every time you do what is it? You feed. You have done to find a cube root or a square root numerically? कभी किया? Any numerical algorithm have you used to solve something? So वो सबसे बड़ा, I mean that's a very important way to think about computing. अगर आपने उस तरह नहीं सोचा, तो आप सोच नहीं रहे ठीक से. Right? So we have to have exposure to one of these problems, non-linear numerical solution. If it is linear, आप matrix inversion से कर सकते हैं, right? If it is something like that, yeah, let's look at that. Suppose मेरे पास ये equation है. How do I find the roots? ये बहुत fundamental problem है. And we have to understand this, the process. How do I find the roots? Anything you can tell me? How would you say, आपके पास computer है, MATLAB है, all the power in the world you have got. So what would you do to get roots of this equation? 3 roots हैं इसके पास. तो क्या करेंगे? क्योंकि अगर जब तक ये दिमाग में नहीं है, this should be at the top of your head. कि how to tackle problems which are not linear. अगर आपकी linear problem है, तो you can always put it in this way. Right? If you have got a linear problem, खड़क से आपका आंसर आ जाएगा. Only you need to know is how to invert a matrix. Compare to that, how do I go about solving that problem, cubic equation? बहुत जरूरी है. जिंदगी में उसके जाने बगैर जिंदगी हो नहीं सकती. वो एक प्रोसेस है. What is the process we use to solve a problem like that? Very, very, very important thing. So this is how the world works. दुनिया ऐसे काम करती है. Yes. Right? दुनिया ऐसे काम करती है, सारी दुनिया. गैस, ये सारी दुनिया का काम है. बड़े बड़े साइंटिस्ट, they always guess solution to a problem first. When you talk to big mathematicians or physicians and all, or physicists and all that, and you say, how did you come up with the solution? They'll always say that I guessed the solution first. ये दुनिया पूरी ऐसे काम करती है. That you have to guess. First you have to guess what is the solution. आपने guess किया. x0 तो आपका guess है ना? Correct? x0 is guess, so it will not be equal to 0. अगर 0 है तो you have guessed the right solution to start with. Okay? Now, ये दुनिया का खेल ये है. The reasons computers are so powerful because they do that. And how to guess that? सारे पैसे इसमें. डेल्टा x हम वो कैसे ढूंढे जिसकी वजह से हमारी एरर कम हो. Or even if we can reduce that error by tiny amount, doesn't matter. Because I can run that algorithm 1,000,000 times. Only thing I need to make sure that this is less than that. And I keep going. So there are many different algorithms. So Newton-Raphson is the most famous one, which does that. It tells you what is delta x, right? You use that delta x, your error goes down, and finally you arrive at the solution. But usme bhi, there are many different things you need to be careful about. Otherwise you will overshoot, undershoot, बहुत झंझट है उसमें. अगर झंझट नहीं होता, so not so many people will be doing research in these things. But झंझट है, that does not matter. What matters is this step 1, 2, 3. That is what your every algorithm you design, you work should have these 1, 2, 3. You guess your initial solution, substitute it there, you find an error, you change your initial solution, delta x, and the error should go down. Clear? Does anybody want to comment on that? कि आपने भी ये किया है, how you have done it and in what, I'm happy to share. Because this is the crux of the matter. कि आपको machine learning चाहिए, artificial intelligence चाहिए, आपको हजार चीजें चाहिए. Unless you have got a feel for this, you cannot understand anything. This is at the heart of everything. कि you have to have a method to get delta x. To get delta x such that the error is less the next time. Right? And one of the methods in Newton-Raphson, there are बहुत सारी झंझट है वो. There are many methods, and people are coming up with methods every day because it's such an important problem. Clear? कोई comment? Okay. लिख लिया सबने? 3 स्टेप लिख लिया? मैडम आपने लिख लिया? Okay. Now, ओके सो ये अपना झंझट हो गया. तो लोड फ्लो प्रॉब्लम क्या है? हर प्रॉब्लम में इनपुट होता है, आउटपुट होता है, हर एल्गोरिथम में. सो इन योर ओपिनियन, what is the input to the load flow problem? Which one? And they are?
Maybe the generation data.
In the sense?
Like available.
Available, okay. So PG, I, QGI, okay. Good. What else would you want to input to this process? If I want to get the process going, think in terms of KCL. अगर आपको KCL लिखना है तो क्या क्या चीजें चाहिए? अगर आपको KCL लिखना है तो आपको लोड की इंपीडेंस चाहिए ना, right? So I'll put one more thing here. Transmission line data. So network जो है, right? What is the third thing you need to give? Current where in? Current in what? Yeah, current we need. Sir, आपने बताया था. Can you tell what is that? What is it we'll need? What is the input to this program? KCL लिखना है आपको, तो आपको impedances चाहिए. What is equivalent of impedances here? आपने ही कहा था सर, आप बताएं क्या है? What is equivalent of? You have a load. You can represent it in many ways. You can represent it as constant impedance. Pardon? Yeah? Reactance, that's correct. So if you are writing for the linear system, we'll need that. वो तो हो गया ना नेटवर्क ट्रांसमिशन डेटा में. PL and QL, load. you will need to have the loads. Right? So you will need to have the loads. If there are no loads, we can't model the network. Because what we are modeling as constant impedance, now we are modeling it as constant current or constant power or whatever. So that can be covered in this. So this is our input data. What do we expect at the output? Voltages. Thank you very much, sir. Delta A. If you want to write it like that. Correct? उसके सिवाय कुछ जिसने किया होगा वही ये बता सकता है. एक और इंफॉर्मेशन हमको चाहिए. It comes out of that. That's a very technical part and that's very very important. अगर आप जाओगे सर आपको काम नहीं करने देंगे if you don't know that. इसमें यह होता है कि we do not in advance know the losses in the network. Okay, so we don't know the losses in the network. So in general, this should be equal to this plus losses. Right? But we don't know before we do this whole business. So after we do this whole business, we will find out that there is a deficiency in power. So that is called slack bus power. So we always keep a slack bus. Jahan we don't tell what is the generation and PGI and QGI. Because that will depend on, after you finish the analysis, that number will depend on that. Okay? So this is how many slack buses are there in the system and all that. This is all very interesting because many times the solution depends on that and many times it's a regulatory requirement, etc., etc. But remember there is a slack bus. Maybe there is another name I'm bhul raha hu. Slack bus. Swing bus. Thank you. So it is called slack bus or swing bus because it not fixed power. It will depend on how the whole thing works out. Right? So now, how would you, ये जो process है, can you tell me how would we do this process with definite instead of X, the things we are dealing with? ये निकाल दिया हमने. तो अब ये मेरे को प्रोसेस बताएं आप. So how did that process start with the cubic equation? Yes ma'am, आप बताएं. क्यूबिक इक्वेशन में सबसे पहली चीज सॉल्यूशन में हमने क्या करी? Very good. And we called it x naught. Here you give me the same thing with the variables we are actually using. कौन से वेरिएबल हम काम में ले रहे हैं? Which variables do we need to find? X naught तो हमने in general, that was an abstract thing. Here we have got a definite problem. So कौन से वेरिएबल हम इसमें ढूंढ रहे हैं? या कहाँ बोले? नहीं, ये आपने देख रहे हो वेरिएबल वहां आपके सामने है. Voltage and angles, right? So we guess the solution, V I naught delta I naught. So we guess. Now this is where some of the insights of power system engineers come. Voltage, you can guess anything. I mean, this is huge thing. What is our normal guess?
1
1 per unit voltage. So इतना wonderful setup है power systems का कि 1 per unit you know what is the base voltage and all that. So we always, that's why load flow, all these things are done in per units. you convert everything to per unit, you guess one per unit, delta I0 you can guess using DC analysis, and there are many different things to do. You can start with 0 also. Okay, and then you churn through the process. Making sense? अपना पूरा पिक्चर आ गया? अपन ने अभी किया नहीं, हाथ से करना बहुत जरूरी है, पर पिक्चर आ गया अपने को. नाउ टेल मी हाउ मशीन लर्निंग कैन हेल्प मी इन दिस प्रोसेस. How machine learning can help me with, so hosting capacity evaluation is simply doing the same, this process 1,00,000 बार, 10,000 बार. The same process, and finding out voltage levels and making sure that they are in the level. जैसे सर ने कहा current is within the limit. So you have to do this process 1,000 बार किया तो आपकी hosting capacity हो गई. You can't do anything other than that. That's what you have to do.
1,000 times different data.
Different loads, different generation, yes. You have to vary. Because you never know what is the load combination, what is the generation combination. So you have to distribute it again, do it again, distribute again, do it again.
Realistic data. Different
Realistic, yes. So utility companies have got it, they do it day and night, this same business. तो उसमें मशीन लर्निंग कैसे हमको मदद करेगी? आपको सबको होस्टिंग कैपेसिटी सीखनी थी.
We are the host.
तो अब आप बताएं कि कहां. मैंने आपको प्रॉब्लम बता दी, एंड आई हैव हिडन नथिंग, एंड देयर इज नथिंग एक्स्ट्रा अदर देन दिस. जो एक्स्ट्रा डिटेल्स है, दे आर डिटेल्स, दे आर नॉट द हार्ट ऑफ द प्रॉब्लम. अब आप सोचें, बिकॉज वी हैव टू थिंक. अगर आप सोचेंगे नहीं तो मजा नहीं आएगा. मैं बता दूंगा तो इट इज नथिंग. सो फर्स्ट टेल मी व्हाट. ओके, हाँ ये चलो, वेरी गुड. यहाँ ये तो गुड प्लेस टू गेट गोइंग. जो मेरी पहले दिन की स्लाइड थी, तीसरे दिन काम आएगी. हाउ डू आई पुट इट? सो वी गो टू मशीन लर्निंग नाउ. ओके, तो ये प्रॉब्लम मैंने सेट कर दिया. Machine learning will do, and you tell me how that what we are going to do can be used to solve the problem. Right? About machine learning, how many of you have done some basic course or something in machine learning? आपने किया? Anybody else? Okay, so we will start from basic. मैं हमेशा basic से ही कर सकता हूँ. My limitation. आप मेरे को अगली बार ना बुलाएं तो भी doesn't matter, but I can only do it in one way. Problem setup हो गया है hosting capacity का, and we have said PV, EV is the same story. कोई उसमें अंतर नहीं है, because EV is consuming, PV is supplying. Right? So load, so this will be positive for EV, this will be positive for PV. So कोई अंतर नहीं है, no difference. Only thing is, how do we set up different, as I said कि 1,00,000 बार 10,000 बार करना पड़ेगा, तो 10,000 केसेस कैसे चुनते हैं, that will depend on PV or EV. But the heart of the problem will not change. Because if it is EV, you have got a bit more understanding of when users come and कितने घंटे लगाते हैं. When PV, you got a different issue. आज बादल होंगे नहीं होंगे, etc., etc. Right? So now we come here. So I would very strongly suggest कि आप सब लोग ये किताब पढ़ें. He's a graduate from IIT Madras. He might be a senior person. Okay. So normally the things which are popular literature, I don't like. I don't mean people don't like, क्योंकि उसमें काफी superficial होता है. ये popular literature है, and yet it has got depth. It has got proofs. This book, I mean, really you should order it for your library. ऑर्डर कर देना लाइब्रेरी को और फिर इंटरनेट से जाकर ले लेना. It is available on internet, but at least do the honest thing to get it in your library, one copy. So उसकी भी सेल होगी. It is available on internet. आपको 1 वीक लगेगा पढ़ने में, 15 दिन लगेंगे. Go through every proof he has got. It is not too much of your time. He has got the proofs, he has got the history, he has got all the excitement of this thing. So अगर आपको machine learning में interest है, और even if you want to look at machine learning as a spectator, यार ये क्या है? This book is a very good book. Okay, 2024, recently it has been published, and it has got all the latest things there.
All the books.
Pardon?
All the books.
नहीं ये नीचे वाली.
Last part.
अनिल अनंत
Last
स्वामी.
page.
Yeah. बाकी books they are highly technical. Sorry मेरे को थोड़ा गड़बड़ हो गया. The itemization should be that वो बाहर आना चाहिए था. So it's another book. But other books are all highly technical. If you want to do research, if you want to do that, you read those books, other books. But if you want to get started, you use Anil Anand Swami's book. Very nice book. Okay? In the sense, it is interesting and it has got proofs. See, अपने धंधे में प्रूफ के बगैर किसी चीज को हाथ मत लगाना. जब तक प्रूफ नहीं है उसको हाथ मत लगाना. Right? So it has got proofs there. Right? So very lovely book and history. So excitement of how this field developed, etc., etc. So you will like it. Okay. So normally मैं लाइब्रेरी से किताब ले आता हूँ, पढ़ी रहती है, पढ़ता नहीं हूँ. पर somebody wanted to recall this book. Normally there nobody recalls. तो फिर I was under pressure कि यार ये तो खत्म करनी पड़ेगी. I'm going to नागपुर also. So मैंने 3 दिन में I finished it. अगर मेरे को यहाँ नहीं आना होता और किसी ने रिकॉल नहीं करी होती तो I would never have read that book, right? वो पढ़ी रहती कि हाँ पढ़ूंगा, कल पढ़ूंगा, परसों पढ़ूंगा. But I have read the book completely, and based on that I recommend read it. Okay? So अपनी honestly अपनी लाइब्रेरी में फॉर्म भर देना कि get that book, फिर इंटरनेट से उतार लेना. Okay? So now we go further. क्या हुआ? Yes. So at the simplest level, we can think of it as a classification problem. Machine learning is a classification problem. That's how people initially thought, and the people who are really who in the know of these things, not people like me who are outsiders, but people who are insiders, they look at these things as classification problem. Classification problem क्या है? You got a function. You put certain जो आपके variables हैं, जैसे you have got a function. You put these variables, right? You put these variables and it tells you whether hosting capacity with these power flows is acceptable or not. Okay? So it will give you 1 if it is acceptable. So this x1, x2 you can consider as v1, delta 1, v2, delta 2, etc., etc. So you give all the variables you have, and then it will tell you, yes, this is possible, that is possible, it is classifying, right? So that's the basic classifier. Now, so classifier is like this, w1 x1 plus w2 x2 plus b, and you can have as many variables as you like. It's a linear classifier because it is a linear function of the variables x1, x2. And if you put the x1, x2 there, if the number is, it comes out to be less than 1, less than 0, it is one class, greater than 0, it's another class. So simple. Now, क्या excitement था? What was the massive excitement about this? How do you get W1 and W2 and B? Let this is a classifier. I know I got several x1, x2 with me, and I want to so I have got So I got these data points. So let's say I got 3 data points, right? I want to classify, or I want to use the linear classifier V1x, W1x1, W2x2 plus B. I put in there x1, x2. If it is greater than 0, it is one class. If it is less than 0, it's another class. But to do that, I need to know W1, W2 and B. Right? I know x1, x2 because that's my data. But the classifier, to design the classifier is to know W1, W2 and B. ठीक है? How do I get that? आप सोचिए. I have got the data. So this data is there. So how do I come up with W1, W2 and B? That's the purpose of this training algorithm. You would have heard the name training. Training का मतलब W1, W2 और B को to find that. तो सोचे कैसे? This you have to think. एक प्रॉब्लम मैंने और आपको ऑलरेडी दे दी है कि आपने डिस्क्राइब कर दी है होस्टिंग कैपेसिटी प्रॉब्लम. हाउ कैन वी यूज मशीन लर्निंग? दैट ऑलरेडी एट द बैक ऑफ योर हेड. सेकेंड प्रॉब्लम इज हाउ टू फाइंड W1, W2 एंड B. कैसे? x1, x2. अब ये क्रक्स है इसका. सोचिए. ओके, सो वी कैन ब्रेक अ बिट अर्ली. हैं? क्योंकि आपको मैं चाहता हूं आप सोचें. So it's a nice point to break and then we'll meet again after tea. पर सोचें कि W1, W2 and B, how do I find them? Given a data set, यहाँ मैंने 3 ही point दिए, maybe I've got 50 points there. So I've got points in this plane, x1, x2. So I've got these points, and then I want a classifier that separates these points. For one set of points, it gives less than 1. For other set of points, it gives less than 0. For other set of points, it gives greater than 0.
Are they initialized random bits?
You can, yes. That's exactly right. So you have to think about that. You can initialize them randomly, 100%. Yeah, you can initialize them. So that's always the starting point. वो मैंने 3 चीज कही थी, वो दुनिया उस पे चलती है. Those 3 things I said, दुनिया उस पे चलती है. You guess. And so we have to, those 3 steps, we have to be exactly what are those 3 steps, so that we can write a program. So आज का अपना काम होगा to write those programs, okay? Thank you very much. Oh yeah.
बढ़िया.
Thanks. Thank you, sir.
How was the presentation, sir? How was that? No, today I will go.
अभी तो नहीं. We have to look at it in the afternoon. So I have got. So what I did was I got HTML. So मकरन सर ने आपको दे दिया था मेरा आज का जो zip file है.
हाँ सर
Okay.
इसमें है
So I'll use the HTML to go through the code. When we'll go to the lab, then we can check on those computers whether it's working or not. So is there a way you can put files
On all pieces.
all PCs?
यस सर
हाँ बस.
कॉमन
कॉमन एरिया में कर देना एंड देन विल सी विल स्ट्रगल थ्रू देखते
So
हैं.
how will be the schedule for that lab session?
आई कैन टेक द लास्ट सेशन इफ यू लाइक.
अच्छा 4 o'clock का.
हाँ
और अभी कंटिन्यूशन में ही चलेगा.
अभी
अप टू लंच चलेगा.
लंच. Is that all right? Because we have to do some basics of machine learning. But the thing is, I hesitate because वो ready-made program है. Okay. So we have to find ways, things to do to that and all that to learn from that. तो उसके लिए थोड़ा background चाहिए. नहीं तो it won't be meaningful. कि ये बदलो उसका क्या मतलब?
Right, right.
तो थोड़ा background हो जाएगा. Then we'll do that.
अच्छा, then 2 to 3:30.
For everything, that folder is meant to be shared with everybody, the entire folder. Because our students who have done that, they have taken away the material which is confidential. They only used data which is publicly available. So it is perfectly safe to share. So I mean, the biggest thing is that they have something which is already working. सबसे बड़ी तकलीफ ये होती है to get it working first time. That's the hardest thing. So if they've got already something working, then they can change this, change that, and do many things. So my intention was to give working scripts, which they can modify and play around and all that. So सारे scripts काम कर रही हैं. And the limited we can do in the class. They have to take it back home, run it, think about it. So the whole idea is to tell what those things are and how they should look at it, and how should they use it in future. Yes, sir, that is how I'm thinking. Okay. Baki, so there are many ways to do things. शुरू करें? सो अब अपने को ये झंझट है कि these points are given. How do I design a classifier which has got W1, W2 and B so that it somehow separates the points? So why was there an extraordinary enthusiasm or extraordinary, how should I say, extraordinary enthusiasm, I would say, hope, once a classifier was designed, once they had an algorithm to design W1, W2 and B. बहुत बड़ी बात हुई. The people who designed that, they went on television, national television shows in 1950s, 40s, late 40s, early 50s. So there was a great excitement. Yeah, excitement is the better word. They had a great excitement once they found out the algorithm to design W1, W2 and B. तो मतलब क्या ऐसी चीज थी? Okay, so let's. So problem समझ में आ गई ना? Problem is rather clear. So now we have it. Okay. कोई बात नहीं. Let's do this. Can you put in continuous scroll? Yeah, jump, because I might need to have previous slides. So scrolling. This is jumping one slide at a time, right? So just PDF view में ही लगा दो.
PDF.
PDF view में just put it there so I can scroll. Yeah. Yeah, that's right. So I can scroll. Yeah, that's right. That's better. That's better. Thanks. Thank you very much. Okay now. So geometrically, how does this classifier look like? So this classifier is the edge of this pink thing down there. So all the points on that line, Wx1 plus Wx2 plus B is equal to 0. All the points in that line is 0. Above that line is greater than 0. Below that line is less than 0. So that is a classifier. So once that classifier is done, everything is classified above left of that line is one group, and the right of that line is very good. That's the starting point. But what is the peculiarity it has to have?
Definitions first. We need to define the variables,
Correct.
the inputs,
Very good.
and then the conditions. On what conditions the input will be processed and what will be the probable output.
Very good. So that is a method. But when you say an algorithm, computer algorithm, we have something which makes it really good. Right? आपने एक general algorithm की बात कह दी, but we have to always think of algorithm in the 3 steps I just gave. An algorithm is a method. At each step, it improves the accuracy of your guess. हर स्टेप पे वो बताता है कि हाउ टू इंप्रूव योर गैस. दैट इज एन एल्गोरिथम रियली. बाकी सब तो ऐसे ही है. दैट यू कैन कॉल एवरीथिंग एल्गोरिथम. यू कैन हैव माइनस बी प्लस माइनस बी स्क्वायर माइनस 4ac, वो भी एल्गोरिथम आप कह सकते हो. बट दैट्स नॉट रियली एन एल्गोरिथम. दैट्स अ स्ट्रेट अवे फॉर्मूला. देयर इज नो इंप्रूवमेंट टू बी डन एज यू आइटरेट थ्रू. So normally algorithm is an iterative process where you improve your guess at each iteration. ये हमेशा दिमाग में रखना. So when you have to solve some problem here and there and you come across this, यार मेरे को कोई वो डिजाइन करना है algorithm, so always think how would my initial guess, how would I improve on my guess as I go along. So that's an algorithm, right? So now we need an algorithm. So ये जो ये है अपन ने डिस्कस कर लिया है. 2 points. Okay, so this simply says, I mean what this is doing is, I have put everything there so that you can go through these things at your leisure. So basically, इस बीच वाले पॉइंट पे वो 0 है. The thing up there is x, the difference in delta x will be positive on the top point, negative on the below point, and you can use this idea that to get to x1 minus, you have to subtract delta x from your x1 star, and x2 star, x2 plus and x2 minus are the same points. So you will see that if you put it there, you will see that जो plus है उसमें it will be greater than 0 और जो minus है उसमें it will be less than 0, right? Because with sheer fact that आप थोड़ा सा वो linear algebra कर लेंगे, so that will be done. So that is the classification algorithm. Now here comes the big punch. So this is the जिसने किया, they called it what? Perceptron. Perceptron. So they called it a perceptron, which takes x1, x2. It can be x1, x2, x3, x4, x5, x6, 100 x is there. You multiply them by w1, w2, w3, w4. Add a bias term b there. You get the output. If output is less than 0, 1 class. Output is greater than 0, 1 class. Suppose you want to decide कि कितने लोगों के पास EV है. You don't have the data available. So you get x1, x2, all the other factors, load consumption, ये वो 1000 चीजें, and there could be, and then you feed it in there, and output will tell you if it is less than 0, let's say they don't have a car, EV. If it is greater than 0, let's say they have got EV. So less than greater than 0 is totally arbitrary. It can be this way or that way. उसमें कोई फर्क नहीं. It is just dividing into 2 classes, right? So this classifier caused so much excitement. So this perceptron, the person who proposed it was on the TV, national TV, and there was a lot of excitement. The reason is this. So we had, how do you find W1, W2? This is how you find. W1 is your guess. Always 3 steps. The first step is your guess. So you can have any method to make that initial guess. It can be random, it can be fixed number 0, 1 or whatever. You make a guess. Okay? Then you put in x1 and x2 through that perceptron. You measure y. Right? एक बार x1 x2 डाले तो y आ जाएगा ना? It's a fixed algorithm how to get y. Once you get y, you update W1 and W2 using this business. Is the algorithm clear? You are able to get a new value of W1 and W2, right? Nothing mysterious there? Right? You apply x1 and x2, you have guessed W1 and W2. So you have got W1 and W2, you guess x1, you apply x1 and x2, it will give you y. That's a definite deterministic process. There is nothing to worry about it. Once you get that y, you multiply it by x1 and have that eta business there, which is point learning factor. We will look at it later, or you can yourself explore it. I mean, we may not have time. These are called hyperparameters. So learning depends on choice of that parameter eta. Okay, so don't worry about it. Most of the people choose it as 0.1 or something. Okay. So we get W1, W2 and B in this way. And then we again apply x1, x2. We get y. We go through the same process again till W1 and W2 converge. They converge to a value and we are home. Now, on a perceptron maybe not convert, perceptron you take all the points and just do that, and whatever when you exhausted all the points, what W1 and W2 you get is your W1 and W2. Okay? अब इसने इतनी क्या परेशानी कर दी?
Eta can be different than 0.1 also.
Pardon?
Eta is can be different than 0.1.
Different than 0.1, yes. It just depends on how good the convergence will be. Okay? Eta can be different. If it is large, then it will oscillate a lot. If it is a slow one, then it will take a long time to converge. So by practice, so that's a big business. I mean, I don't know किससे मैं कल बात कर रहा था. People at Google and all, they give out these results for reinforcement learning and all that. And to us it seems very easy, but they know how to choose these parameters like eta. अपने बस की बात नहीं है for complicated problems. It needs lot of experience. But for this simple problem, 0.1 will do.
You need experience.
Yeah, experience. You need experience, lot of experience. So machine learning, you have to be very careful that hyperparameters. So these are called hyperparameters. Learning rate and all that. Those things become very important to get the right result. Okay, so, but it does not matter. So let's assume that somebody has chosen the right hyperparameter, and people do end up choosing the right ones and do hundreds of things, right? So now, with this story there, why there was such a massive excitement with these 3 lines of code? क्या उसने ऐसा कर दिया कि people got crazy? Can you look at those 3 lines and what appeals to you? What information you need to classify the points? So write it in your notes or think looking at those 3 equations. What is the information you need to go through that process? Update process. Pardon? वो इनिशियल गैस करेक्ट डन, उसके सिवाय सेम इनिशियल गैस डन, उसके बाद एक्सो मतलब डेटा है आपके पास अवेलेबल है, वेरी गुड, दैट इज द डेटा somebody has already given to you, and then so to do that, what all we need x1 x2 and we need the initial guesses. What else do we need? ये जोर से वो ईटा भी दे दिया आपको किसी ने, given hyperparameter. Where is our that fellow? bug boost guy. कहाँ गायब हो गया वो? Did you call police?
भेज दो.
Okay, so x1, x2 we need guess of w1, w2 and b. What else we need? ध्यान से देखें. You are in the right direction. What else we need? Just look at the board. क्या क्या है? लिख लें आप क्या क्या वेरिएबल है वहां लगे हुए हैं. क्या क्या है वेरिएबल वहां? क्या क्या वेरिएबल हैं? You need the output. Why? Is that right? But you don't need the true value. Sir, आपने कहा true value कहा ना आपने? You don't need the true value. That's why it caused such a great excitement. You don't have to tell it anything. You just give it the data. Output is part of the thing. You don't have to tell. You select W1, W2 and B, and output comes out of that. So it is self-learning, unsupervised learning. Nobody tells what is true, what is not true. That this thing belongs to that class and this thing belongs to that. It separates the things by itself. So that was the big hope, that computers are intelligent enough to solve all our problems. Because we are not telling what is the right solution. We are not telling the right thing. We are just giving the data. We have got this algorithm which does not need our instructions on what is the true output. It simply does it on its own. उसका बहुत excitement था. You appreciate the beauty of this algorithm. You don't need anything. You just need the perceptron and you have to initialize it. You go to data and initialize, you can initialize it in a million ways. And then finally it will come up with the line which will separate the two things. ठीक है? तो अब अपन ऐसा करते हैं, आप सब नोट्स में करें. Huh? Output, this is clearly defined output y. Okay. That's y clearly defined. So z equals to w1 x1 plus w2 x2 plus b2. W1, W2, yeah, that's right. And y is maximum 0 and z greater than 0. If it is less than 0, the output is 0. If it is greater than 0, whatever is the output. It's very well defined. कोई झंझट ही नहीं उसमें. Clear? So अब आप मेरे लिए ये करें. I should not risk it like that, but चलो कोई बात नहीं, आप माफ कर दोगे. But these are the 2 points you are given. Please design a classifier using this algorithm. ये आपको हाथ से करना पड़ेगा. यहाँ मैंने 4 पॉइंट दे रखे हैं, आप अपना 2 पॉइंट से अपन शुरू कर सकते हैं. आपको मशीन लर्निंग में गुरु होना है तो थोड़ा काम तो हाथ से करना पड़ेगा. ये एकदम फिट यूपीएससी का मामला है, में कोई सोचने समझने की बात नहीं। यूपीएससी का मामला करना पड़ेगा सर आपको, सर आपको करना पड़ेगा। आपने कर लिया? तो करना पड़ेगा ना ना, वो सर्टिफिकेट लाओ, मेरे को फाइल दो। मेरे को फाइल दो।
For that you have to the other.
अरे भाई उसके बिगड़ नहीं चलता भाई, ये बहुत छोटी,
Those who have done, please help them.
बहुत छोटी चीज है ये, बड़ी नहीं है। मतलब व्हाई आई वांट यू टू डू नॉट टू पनिश यू बट फॉर यू टू रियलाइज दैट ये कितनी छोटी चीज है। अगर आप खुद से नहीं करेंगे तो कभी आप उसको स्वीकार नहीं करेंगे, हमेशा लगेगा साला कुछ है उसके अंदर। आपको एक्सो लाइट कर दें तुम्हें भी, लाइट का चक्कर है। ओके If you have any doubts, see the reason we do all these things is that sometimes things are not clear. So you have got all the right to ask me. So remember again the process W1 and W2 and B we initialize randomly. आप चाहे जिस तरह चुन लें. Once you do that, then you get Y for 1 point. You update W1 and W2 with that. Then you get Y for another point. You update W1 and W2 with that. And when you get that, you draw that line and let's see what classifier you come up with. आपकी मर्जी है. हाँ, एक वो तो दिए हुए हैं, डेटा आपको दिया हुआ है. You can start with 0, 0 और 1, 1, आपकी मर्जी है. Pardon? Y का फॉर्मूला. Sure. So ये नोट कर ले, मैं नोट कर लेता हूँ. Y is maximum. So it will be either 0 or 1, right? Huh? B कोई भी आप, you can choose whatever you like. You can initialize any way you like. हो गया मैम? ये फोन बड़ा तकलीफ की बात है. आप को लाइन ड्रॉ करें ना. हाँ बोले. हाँ करेक्ट, ये परफेक्ट है, बट आपको वाई निकालना पड़ेगा ना पहले. हाँ ये आपको वाई की इक्वेशन दी है दो, आप वाई निकालना. वेरी गुड. मैम को छोटी सी समस्या आई और इन्होंने फोन पकड़ लिया. दैट इज, मैं भी वही करता हूँ. आई डू दैट. छोटी समस्या, फोन पे समस्या नहीं ना. यस सर.
कुछ नहीं, मैं गूगल कर रहा हूँ.
गूगल आप करें. गूगल, आई डोंट माइंड. यू कैन यूज चैट जीपीटी, यू कैन यूज गूगल. आई डोंट माइंड एट ऑल. आपको जवाब मेरे को चाहिए. आप कैसे जवाब देते हैं, आई डोंट केयर.
वो बोलता है मिसिंग इन्फॉर्मेशन. बंदे को इन्फॉर्मेशन.
तो अब ये तो आप जाने. यस yes.
I got these two values, y as 1, 1.
So okay, so this was okay. y1 तो पहले ये z is 0.1 so y1 so इसमें आप अपडेट करें yes and then use this to get the next y right and then update it again and then plot it anything I can help you with that's all right but apna procedure is very clear we have got these 2 points x x1 x2 x1 x2 we put it in that formula here z we find out y then we use that algorithm to update z1 w1 w2 to b ये बड़ा सुनहरा मौका है
Z is coming as 2 then.
it's 1 so z greater than this is a logical thing so 0 so logical what will be the logical output of this statement z greater than 0 if z is 2 what is the outcome of this statement 1 because logical is always 0 and 1
It's a logical. It is a logic.
logical variable so it is always 0 and 1 yes but maybe you can try there are many different types of non-linearities yes sir
If initially I take all three as one,
perfect
so I first calculated
yeah
and then y is maximum between 0 and z, so it is 3.
1
3
1 so z greater than 0
or z, na?
z is greater than 0 right so logically अगर z 3 है
Okay.
So
I thought maximum between 0 and z. I
okay
thought-
that's all इसमें कुछ ऐसी बात नहीं होता the way of writing so when they write it's equal to or greater than or that's a logical variable and logical variable can be 0 or 1 उसमें कोई बड़ी बात नहीं है
So guys should take y is equal to
1 पर 3 में भी आपका देख लें what line you get doesn't matter
Okay, I took 3.
Yes.
Then I updated W1 by this equation.
correct
We got this.
Yes.
Similarly W2
yes
and then B.
correct perfect
So I got this W1, W2.
Yes.
And this step is repeated.
repeat it correct perfect और फिर once you finish those 2 steps then you plot that line you'll get a equation of a straight line you plot that मैडम आपने plot करी equation
I'm not understanding what to do after this.
तो आपका very good so once you have this so this is an equation of a straight line so you have to plot it on this same yes
Y equal to 1. Y in 1. Y in 1.
हाँ तो कहाँ है आप so W1 W2 क्या है बताएं and what is B हाँ तो क्या है कितनी वैल्यू है B की हाँ तो क्या करनी पड़ेगी ना वेरी गुड बिलीव मी इट विल बी वेरी सेटिस्फाइंग just to share an experience with you, for years I let students use MATLAB, internet, everything they can use for their exams and class tests. इस साल मैंने उनको कहा चैट जीपीटी भी काम में लो राइट अब चैट जीपीटी को पायलट जो दुनिया की भर की चीजें काम में लो द रिजल्ट्स वेंट डाउन बिकॉज जब मैं व्हेन यू गिव आउट द पेपर्स यू हैव टू बी देयर फॉर 10-15 मिनट्स टू सी किसी स्टूडेंट को क्वेश्चन है या नहीं है वो सब यही कर रहे थे फोटो लेकर चैट जीपीटी में लगा और किसी को आंसर नहीं मिला एंड वेरी सिंपल क्वेश्चंस I did not set any difficult questions. It's the same questions I've been setting for years. तो उसमें बहुत खतरा है चैट जीपीटी में unless you have used it, sometimes it's hard to get the right answer. But if you know how to use it, it's brilliant. So I wanted students to learn how to use it. Instead, they thought that they will go to the exam, take the picture and get the solution. उन्होंने उसके पहले भी कर लेते वो कि चैट जीपीटी ऐसा solution नहीं देता तो they would have been all right. आपकी लाइन मैडम कहाँ
2 now.
Yeah.
So why will it always be 1?
1 or 0, yeah. Either, if it is 2, it is 1. Yeah.
So it will always be, I think, because as I have chosen this value.
Yeah, that's all right.
Why 1 ही आने वाला है हमेशा.
Okay, कोई बात नहीं. अब finally you get that and plot this line. Plot this line and let's see where we go. That's a straight line, right? W1x plus x0 plus W. तो उसको plot कर लो. काम खत्म.
W1, W2, again I will get W1, W2.
Yeah, दो बार.
दो बार आया.
दो बार. So दो बार तो final जो second बार आया, use that to plot that line.
We have to stop it for second time.
Second time, huh? You can go and see whether it changes or not. You can do that. If it is a computer, you can do that. But अभी दो बार करके we plot that line. Yes. अरे नहीं मैडम, आप क्यों इतनी तकलीफ करते हैं? ये मैंने आपको फॉर्मूला दिया है ना, ये फॉर्मूला आपको वो यूज करना है ना. आप अपने बना रहे हो फॉर्मूला. गुड. आई मीन आई एम जस्ट जोकिंग, बट यू टू यूज दैट फॉर्मूला. ठीक है, बट कहाँ उसमें आपने यू हैव यूज्ड इक्वेशन 6 और नॉट? नहीं काम मिली ना आपने? नॉट इक्वेशन 6 up there on the board. Have you used that to update B? तो वो तो करना पड़ेगा ना. So you're getting that line, right? Okay.
Point 1, 0.
Whatever it is, so you got a line. And now what does that line tell? That what has it done? Pardon? Very good. So your automatic classifier has worked without telling them what it is. So if you got, we did it just 2 for हाथ से करना है. But if you have multiple points, it will do the same story. And you will get a classifier without telling anything, just the data points. So we have got at least one. ये आपने कर दिया ना? That's fine. तो आपका, that's all right. It has not converged. Okay, that's all right. So you might want to do it a few more times. So that's all right. I mean, there's nothing much you can do. This is what it comes out. So with experience we learn. So आपको process समझ में आ गया ना? Yes. वो Srinivas, he has got it right classifier. But he started the right W1, W2. Okay, so we have to go multiple times, and they say that you have to select it randomly. Yes, sir. This line. So W1 क्या है आपका?
Sub 1, 1,
1, 1, 1.
but I take here y as 1.3.
That's,
Sorry, 3.
that's all right. So आपका final W1, W2 क्या आया?
This is now second iteration.
Yes.
So I got W1 is equal to 1.69,
ठीक है.
W2 1.69,
Yes.
and B is 5.3.
Yes. So B is 5.3. So equal to 0, right? So आपका, so you are sure this is the, so your line will be, in our familiar terms, it will be x2 equals minus W1 on W2 minus B on W2. X1, sorry. So the slope of your line is this, and the offset is that. Okay, I'll write it again. So that is the equation of your straight line that you need to plot. Right? And it is, some of you might get the classifier right, some of you may not get the classifier right. And the trouble is that we are 2 points and we are doing just 2 iterations. If you do multiple iterations, you are most likely to get there. There is a proof that Anil Anand Swami's book, there is a proof that if the points are separated like that, 100% guaranteed that you will come up with a classifier. So there are few conditions. One is that it should be initialized with random variables, W1 and W2 and B, and then you have to do it enough number of times to get the classification. Okay, so, but what is the most important thing here is that we have used a machine to classify a data without telling the classes itself. It has separated things into 2 classes without our involvement. That was the cause of greatest excitement. कि हो गया, now we have got machines. So तब तो programming में भी बहुत time लगता था. Even to program a thing like that was a big task. Fortran cards करो, ये करो, वो करो, बहुत झंझट का काम था. Computer भी इतने room की तरह बड़े-बड़े होते थे. So it was a great excitement. So now I think if I can give you one answer which Srinivas ji got, that's the answer he got. But that's a factor of initializing it right and all that, doing it enough number of times. So if you do it, if you put the, so this, अगर आपने अभी नहीं करा हो तो please do it, complete it. ये जिंदगी में बड़े अनिवार्य है. If you want to benefit from what we are doing right now, right? Right? So complete the process, or you can program it on a computer. Just set it up in loop and you are done. So the idea here is that we have set up an iterative process where the classification can be done in an unsupervised way. Sorry, I should have done this, what problem I gave you today myself, but that's all right. This is what we have. So we have got 4 points. And suppose we start like that. What line we have got? The first one on the left top, iteration number 1. We start like that. And you can start it, you can try. I mean, the script is with you, MATLAB script is with you. You can initialize at different points. Having initialized at different points, right? You can initialize at different points. So this is how I initialize. The second one was there. The third one was there. The fourth one is there. So it is almost converged. Right? So just the algorithm we had, Hebb's algorithm, we got this answer. So you should, I have got MATLAB script is with you, or any case Srinivas ji will email it to you. So you can use that MATLAB script in the lab this afternoon and play around with different initialization of W1, W2, eta and all that sort of stuff. Okay? Now, it's not enough that it works. So we have to, any questions? Anybody who is not clear about the process? I mean, the steps are clear. Maybe the answer you got or maybe numerical mistakes you made, that's acceptable. Not a problem. But steps, madam, आपका B का वो सब हो गया? आपका B क्या आया? ये तो आपने दूसरे प्रोसेस से किया ना. इस प्रोसेस से करते आप तो it would be different. Okay. So you have to do the three things, right? So any question about the process? कि process clear नहीं है तो please ask me. Because I don't want you to go away thinking that यहाँ कुछ यार जादू है. कुछ जादू नहीं है. Everything is very simple. And it's a question of choosing right eta, right W1 and W2. So if you did not get what Srinivas ji got, that should show you that the right output depends on many different things. What process you did is perfectly all right. There is nothing wrong in what you did. You picked up some W1, W2, B, went through the thing, your classifier was different, that's all right, that's perfectly normal. So now the thing is how important it is to pick up W1 and W2 and B, initial ones right. How important it is to have eta right. So those are the things. So when people go machine learning, तो जो करते हैं उनको इसका बहुत अंदर से आइडिया होता है कि कैसे चूज करना है. And if you want to get somewhere in this business, you have to get that अंदर का आइडिया कि अपडेट एल्गोरिथम क्या होता है. अगर आप अपडेट एल्गोरिथम नहीं समझे तो आप मशीन लर्निंग कभी नहीं समझ सकते. और करते हैं लोग, हजारों लोग करते हैं मशीन लर्निंग, बट बिगर समझे भी कर सकते हैं. कुछ मैटलैब के रूटीन है, पाइथन के रूटीन है, पर अगर आपको समझ के करना है तो यू हैव टू अंडरस्टैंड द अपडेट लॉ कि कैसे अपडेट किए जाते हैं पैरामीटर्स W1, W2 and B of your linear classifier. Okay? So linear regression is a big thing, right? वो छोटी मोटी फील्ड नहीं है, वो तो जबरदस्त फील्ड है linear regression, right? But उसमें the maths involved is quite a lot. यहाँ क्या maths involved थी? What was the maths that was involved here? ये तो बच्चों का काम है. ये एल्गोरिथम तो बच्चों का काम है. So machine learning is powerful because in a very simple way it makes a very tiny advance in your guess. Tiny is all right because you can run that program a million times like that. Computer does not care. But you should get the idea that we make an improvement on every step. Okay? Like what you see here. So we didn't plot, जैसे आपने, you calculated W1, W2, B, you did not plot 3 straight lines. Your initial guess, after the first point, after the second point. So then you can see like what I have plotted here. कि how you have improved your classifier. अभी दिख रहा है clearly. Okay, yeah, that's a very interesting point. Okay, sorry. The reason I chose this, I didn't tell how to separate the points. Why wasn't it happy with the first classification? Why did it end up on the 4th classification? हमने थोड़ी बताया पॉइंट्स कैसे क्लासिफाई करेंगे. हमने ये नहीं कहा कि आप ये करो और वो करो. Which to your mind looks a better classifier? कौन सा क्लासिफायर अच्छा है, ये नंबर 4 वाला और नंबर 1 वाला? नंबर 4. Why? नहीं, वो आप वही बात दूसरे शब्दों में कह रहे हैं. आपकी बात सही है. क्यों वो क्लासिफायर इज बेटर? Practically speaking, you got 4 points. What is the natural grouping? Are these 2 points close on the top and bottom? They are not close to each other. So that is, although it has done a classification, But that's not a good and practical classification. When it comes down, that's a practical classifier because it has separated two groups of points which are far apart, not points which are close to each other. So ये कुछ बहुत बड़ी चीजें हैं which was achieved in this type of classifier. And without telling, ये मैंने नहीं कहा कि those you have to separate those 2 points. I said separate these points in 2 groups. That's it I told. Nothing more. And you see it picked up the natural classification. सही कह रहा हूं मैं? Anything? Any clarification needed? या ओके वेरी गुड आपका पॉइंट मैं अभी वो जवाब दे रहा हूं ठीक है ये तो आप मानते हैं कि वो क्लासिफिकेशन हुआ यू कैन लुक सो व्हाट आई एम ट्राइंग टू कन्वे टू यू माय फ्रेंड्स इज देयर इज लॉट दैट डिपेंड्स ऑन हाउ यू पोज द प्रॉब्लम हाउ यू इंटरप्रेट द रिजल्ट्स हाउ यू चूज द वेट्स ये बहुत कला है एंड if you just let Python do everything, yeah, Python कर सकता है इसमें कोई ऐसी बड़ी बात नहीं. But if you want to make a mark, be a good researcher, make a difference in research, you have to understand all those things, right? अब मकरन जी का question, if I do more, what will keep happening? So ये काफी बड़ी मतलब this is the way the proofs are done. So let's say that's the vector W1, W2. Right, W1, W2 number, that's the vector. And that's the classifier, what you see there. So, geometrically speaking, the classifier is perpendicular to the W1, W2 vector. Is that statement clear? वो perpendicular है. नहीं, looks तो मैंने बना दिया perpendicular. But I'm telling that it's a matter of fact that we'll go and look. We'll prove now that they are perpendicular. W1 and W2 vector is perpendicular to the classifier. Right? So that's the first thing. And why it is so? We will prove that it can be shown that is orthogonal. Let B equals to 0 doesn't matter because vector shift हो जाता है तो उसका angle थोड़ी बदलता है. B is 0. Then x1 is equal to 1. So I just chose the point. x1 equals to 1, x2 equals to this. This means that 1 minus w is a vector along the classifier. ये आपको समझ आया. x1 is 1, b is 0, so x2 will be 0. So x1 is 1. So our classifier is what? W1 x1 plus W2 x2 plus b equals to 0, right? So I am saying b equals to 0, right? x1 equals to 1, then x2 has to be minus W1 x1, क्या करूँ मैं? I think that's right, yeah. Minus W1 on W2 minus b on W2, ये 0 है. So x1 is 1, x2 is minus W1 and W2. So आप W1, W2, 1 minus W1, W2, 0. Okay, vector multiplication, dot product, 0. So when there are two vectors with dot product 0, that means they are perpendicular to each other. So we have shown. So there is no loss of generalization in choosing x1 equals to 1. You can choose any number, doesn't it? Because for every x1 and x2, the classifier is there, right? There is point. कोई भी point, एक line है उसमें कोई भी point select करके आप vector बना दो. Is that right? no loss of generality in picking up x1. So these are the things you have to think. That had I taken x2, what would happen? x1 equal to 2. तो आपको ये शंका ना रहे, अगर मैं x1 equals to 2 लेता तो क्या होगा? The x2 equals to minus 2 w1 on w2. So आप ये भी करके देख लें. x2 so okay. So ये वेक्टर है. So then this vector becomes w1 w2 2 minus 2 w1 w2 and it goes to 0. So it doesn't matter which x1 you pick up, you will get the same answer. आपके पास x1 कोई भी pick up करे, so it will give you a vector along that classifier, and that vector is always orthogonal to the vector w1 w2. अब इसका क्या झंझट है, क्यों हम इसका चिल्ला रहे हैं? Why are we making it an issue? वो मकरन जी का क्वेश्चन आंसर करने के लिए we are making it an issue. Okay. So थोड़ी सी मेरी यहाँ गलती हो गई. This okay. So this will rotate the classifier clockwise. Okay. So now अपन ये देखें. So let's look at this carefully. What have I got? So I'm assuming that x1, x2, w2 is greater than 0, w1 is less than 0. Is that assumption valid? I am assuming that the data I have got has this feature. Right? x1 and x2, who tells me about x1 and x2? I tell you. So I can choose anything you like. And then if x1 and x2 are positive, then w1 and w2 have to have different signs, because they should add to get 0, right? So one has to be positive, another negative, right? So done this way, and then y. So ये point कौन सा है? ये point ये ऊपर वाला है, plus point, ये वाला point ऊपर वाला. I have picked up that point x1 plus, right? So what will be in that point? So y will be greater than 0. So your y is 1. So यार मैंने algorithm मिटा दिया. So y is 1, right? Are you convinced y is 1? Why would y be 1? Because, okay, y is 1 for a simple reason that y is here. x1 plus x2 plus. So this x1 star, x2 star. At this w1 plus w2 x is 0. At here it is less than 0. That's what we proved earlier. अगर आपको विश्वास नहीं है तो you can go and prove that. That this y will be 1 here, 0 here. Right? So let's put that point y here. So w1 is less than 0, w2 is greater than 0. So what would this vector look like? Can you plot that vector in your notebook? w1 is less than 0 and w2 is greater than 0. Can you plot that vector on the same? So this is, let's say this is w1, w2, w1, w2 like that, and it is also x1 and x2. Can you draw that vector? w1 is less than 0, w2 is greater than 0. अरे सर आप तो क्या यार, वो लक्ष्मी जब आई तो आप मुंह धोने गए हैं? अरे मैं कह रहा हूं दिस इज वेरी यूजफुल। आप यहाँ आए हैं इतनी मेहनत करके, अभी मेरा चीखना चिल्लाना सुन रहे हैं, कुछ तो आपको वापस लेके जाना पड़ेगा। इन हिंदी देयर इज अ सेइंग कि आप मरे बिगर स्वर्ग नहीं जा सकते हैं। किसी को कह दो कि यार वो मर गया मैं स्वर्ग चला जाऊं, ऐसा नहीं होगा। आपको सब काम हाथ से ही करना पड़ेगा। W1 is less than 0 and W2 is greater than 0. So where will be the vector W1 and W2? That's correct. So now आपने कर दिया ठीक. So find out where is delta W1 and delta W2 using that point. अपने point दिया अपन ने, this point. We are going this point. So y is 1 for this point. So find out what is the correction to W1 and W2 using that point. Okay, you have got this one here. So whatever, so we know that I have W1 is less than 1, so I want to find W1 plus eta yx1, W2 plus eta yx2. So I want to find these two numbers to tell me what is the change in W. What is the change in W? जिंदगी का मजा आ जाएगा। ये सब चीजें जरा बैठ जाएंगी दिमाग में, फिर बहुत मजा आएगा जिंदगी का। What is the change in W1 and W2 when I use x1 plus and x2 plus as the test point? Right? मैं इस एल्गोरिथम में डालता हूं, इसमें I put in this algorithm this point. For this point I know what is y for this point. What is y for that point? बताएं? If that's a classifier, what is y for that point? 1. That's right. So you know 1. You know y, you know x1, you know eta. Right? So you can find out the change in W1 and W2. So draw the new vector W1 and W2. Just this one. W1 is less than 0, W2 is... So आप कोई भी vector draw करिए and draw the classifier perpendicular to that. So what I want you to do is W1 and W2, most of you might have got it this one, W1, W2. So I want you to draw the next W1 and W2. Yes? Very good. Very good. So where is the classifier rotating? How is the classifier rotating?
Is rotating clockwise
It is going away from the point.
from that point, right?
फिर दूसरे में अगर आप नीचे को करोगे तो ऊपर को धक्का देगा। तो इस तरह धक्का देते देते किसने कहा था उन्होंने मशीन लर्निंग का कोर्स किया? सर आपने किया था? तो बताएं सबको, आपको वहां होना चाहिए। मैंने तो कभी नहीं किया मशीन लर्निंग का कोर्स। बताएं, कंटिन्यू प्लीज। जिंदगी का एक बहुत बड़ा असूल है while learning that most things are much simpler than you think. मैं इसीलिए यहाँ इतना चिल्ला रहा हूँ, चीख रहा हूँ, कर रहा हूँ, आपको एहसास दिलाऊं कि ये चीजें आसान हैं. यस सर.
This is initial W1,
Yes.
W2. Then I got this W1, W2.
वेरी टू ड्रॉ करें, वेक्टर ड्रॉ करें सर.
हाँ, तो ये इधर आ गया,
ये
इधर आ गया.
वेरी गुड, वेरी गुड. सो हाउ डज द क्लासिफायर चेंज?
Classifier is rotating in clockwise direction.
तो पॉइंट से दूसरी तरफ पुश हो रहा है. अगर नीचे वाला लोगे तो पॉइंट से उधर पुश करेगा वो. तो दोनों धक्के मारते मारते वो बीच में आ जाएगा. Okay. तो धक्का मुक्की बहुत होगी पर वो अपना अच्छी जगह आ जाएगा. राइट? एंड इट विल क्लासिफाई बाय इटसेल्फ. आप करते जाएं, आइट्रेशन करते जाएं, फाइनली इट हैज टू लैंड अप बिटवीन टू लार्ज ग्रुप्स. बिकॉज धीरे धीरे आपको मालूम पड़ेगा पूरा ग्रुप इधर धक्का दे रहा है, पूरा ग्रुप उधर धक्का दे रहा है. एंड जितना दूर होगा उतना धक्का ज्यादा लगेगा. देख लर्निंग. या आपका इंटेंस डिस्कशन चल रहा है, बताएं. हाँ ये चलो ओरिजिनल है तो नया कहाँ है? ये कोई बात नहीं, आपने वहाँ ड्रॉ किया, कोई बात नहीं. आपको बी है, बी आप निकाल देंगे तो यहाँ हो जाएगा. डजंट मैटर. राइट? तो नया वाला कहाँ आएगा? ये तो पुराना वाला है. नहीं पुराना, हाँ पुराना ठीक है यार, सॉरी. नया वाला कहाँ आएगा? तो चेंज इन W1 इज पॉजिटिव और नेगेटिव? कैसे चेंज? चेंज इज दिस नंबर, ईटा इज 0.1, y इज 1, x2 इज 1. सो ये पॉजिटिव है. और ये भी देखो ईटा y x2 सब पॉजिटिव है.
Ultimately, our W1 will go away from our origin.
या सो इट विल, इसी में बताएं मैडम, अगर W1 कम हुआ तो कहाँ जाएगा वो? हाँ एग्जैक्टली. तो बना दे वहां बीच में, इसी पे बना दे ना मैडम. हाँ ऐसे, हाँ बस. और अब क्लासिफायर ड्रॉ करें विच हैज टू बी परपेंडिकुलर टू दिस. या अब दूसरा क्लासिफायर ड्रॉ करें. So if you continue with that process, what you will see is that यहाँ गलती है, मैंने गलती करी है. The first one, this will rotate the classifier clockwise, and the x1 minus and x2 minus will rotate it anti-clockwise. So ये धक्का मारेगा. This point x1 plus x2 plus will push it clockwise, and x1 minus and x2 minus will push it anti-clockwise. So when you iterate through it, you will end up somewhere in middle. Depends on how many points are there. तो धक्का मुक्की अगर नीचे ज्यादा points हैं तो वो ज्यादा धक्का मारेगा, because every point will give a धक्का, so it will move more. So this way it will come to an equilibrium and it will classify. ये basic classifier है. ये और सब इसमें मैं ये स्लाइड अपडेट करके भेज दूंगा आपको. सो डोंट वरी, दिस यू विल हैव द स्लाइड विद द राइट करेक्शन. आई हैव करेक्टेड क्लॉकवाइज एंड एंटी क्लॉकवाइज. सो दैट्स द स्टोरी. ओके, अब कहाँ जाएं? यही था, ये विल डू दिस. ओके, दी अपन करेंगे आज लैब में. ओके, ये बड़ा पॉइंट. यार पानी होगा. सॉरी, Oh, sorry, Amna. Next time I'll take sorry, Amna. Okay. So now, this is a very simple one. And as you all realized, some of you realized that the first set of iterations didn't give us the right classifier. For some people it got, some it did not. That's all right. Now, if I say that I know that two of these elements, two of these points are in class 1, two are in class 2, get a classifier and use that classifier to classify future points. I've got limited data, right? मेरे पास 10 household का data है, right? And I know this guy has got EV, this guy does not have an EV. So I train my classifier based on what I know. अभी तो कुछ knowledge नहीं था. It was unsupervised. So what changes I need to have to classify data where I know what is the true value. अपने किसी friend ने कहा था यार, you should know, use true value. So now we come to that. So true, if I know the true value, how I can make it better? So then 10 लोगों के पास मालूम है, मेरे को मालूम है 5 लोगों के पास EV है, 5 पे नहीं है. So I use this process to train it, giving the true value. And then when the 11th person comes, I use the same classifier to say that this person has EV or not EV. Okay, or maybe I train it on 10,000 people and whatever it is. So that's a normal process. I train my classifier. The first thing we did, unsupervised. I did not know the truth value to anything. Now I'm giving truth value. I know 5 houses or 50 houses or 500 houses have got EV and 200 houses don't have an EV. I use that data to train the classifier. And let's see how do we do that. So, ma'am, aapse, what are the 3 things we had for an algorithm? Yeah. Arey, baitho.
First, variable
Yeah.
definition.
Yes, yeah, that's done.
Next, iterations.
Yeah. So how do we start the iterations?
How to
How do we start the whole process?
defining the variables.
Yeah.
Next, constraints.
Yes? ये UPSC वाला काम है. That is not what we discussed. After UPSC के रट्टा लगाया.
Iterations.
How do we start the iterations?
By assigning the weights.
By?
Assigning the weights.
Very good. Assign the, yeah?
Weights and biases to the system.
Yeah, in some way. Initializing, right?
Huh.
Initially, very good. And then what do we do? Yeah? Update those estimates.
For the next step, we use that updated estimates as the initial conditions for the next iteration.
And what, very good, and what we expect from the updated estimates? What is our expectation?
Accuracy.
Correct?
It should go in the right direction.
Error should reduce, not minimize, reduce. वो 1 million लगता है minimize में. Yes, sir.
If the error is not reduced,
Yeah.
then we have to continue with the earlier.
Exactly. उसका सब बहुत झगड़ा है. See, you are right. Sometimes error is not reduced; it keeps increasing. So we have to forget that. Try something else. Yeah, you're 100%. All what you are bringing up are the actual practical issues in using machine learning. Right? So we make the initial guess. We see how to modify the initial guess to reduce the error, and then use the modified, updated ones and go through it again and again and again. Right? And you can program a computer very nicely for that, and you are done. So now, how do we do that? अभी तो अपन ने वो Heb's का algorithm what we used, but it was a very simple one: output multiplied x1, and then it did the job. Now we come to I suppose that's the only algorithm there, steepest descent. I don't think there's any other algorithm other than steepest descent. Right? So steepest descent, what does it do? I have an estimate x naught, and I want to get delta x so that my function value f is my function, is lesser fx plus x naught plus delta x is less than fx naught. So I have to minimize fx1, x2, xn, choose x1 0, x2 0, xn 0, find delta x, delta x1, delta x2, delta xn, such that f x1 plus delta x1 less than. Is the problem clear? I want to change the value of x so that the next value is less than the value I already have.
If I'm not wrong, when we give like that less than, greater than, maximum, that is constraints only, na? Constraints are conditions for us. No?
Oh, objective function. Constants are different. There are other. So f here is our objective function. Constants will be inequality constants, equality constants. All those are there. So then there are many ways to include constants. So let's look at the unconstrained problem now. Okay?
Single objective.
Yeah, single objective, correct. We understand that well. So now, this has question, what is the direction along which this is maximum? The rate of change. Okay. So what this second point says is that this will be most useful if I find out the direction along which f changes the fastest. Does it make sense? Because I need to make some change. And it is logical to make change in the direction which makes the change fastest. Clear है वो बात? Yes sir. साफ है? I have to go down. I have to take a step. So I should choose that step where the change is the fastest. You might go down and you might decrease, but the best thing is to go in the direction where the change is the fastest. So we have to work out in which direction is the change fastest. और उसको कहते हैं steepest descent. उस डायरेक्शन को कहते हैं steepest descent. क्यों? What does this? याद आ रहा है कुछ? How did I write this one? Number 8. Yes, क्या अब मैंने थ्योरी लगाई है to get fx0 plus delta x? मैं हर चीज के लिए कहता हूँ जिंदगी का आधार इस पे, पर वाकई में उन सब चीजों पे आधार है. These things form the fundamental blocks of everything we do. So बताएं ये कौन सी इक्वेशन है, मतलब what rule I have used, what theorem I have used, what result I have used to write this line. नहीं, load flow नहीं मालिक. What is the theorem? I have got fx plus, I want to, okay, let me do it another. I know fx naught I know. I know f x naught. 5, 10, 15, 20, 100, 150. I know that. I want to find given delta x, I want to find f x naught plus delta x. आप समझ रहे हैं? एफ एक्स नॉट की वैल्यू मैंने दे दी 100 है, और डेल्टा एक्स आपको दे दिया 0.1, 0.2 होल वेक्टर, और मैं आपको कह रहा हूं कि गिव मी द वैल्यू ऑफ दिस थिंग. So what this is saying is the value is simply the original value plus the rate of change of that function with respect to that variable, and then delta x. अब rate of change लगा दें और कितने गए, right? जो उतार है, something is going down. So how much down you will go depending on the rate of change and the distance traveled. Correct? Simple. What is that result called? Taylor's theorem. It's a very, very famous theorem. और आपको सब लोग बोलते होंगे दुनिया में कि this world is really non-linear. There is nothing linear in this world. We linearize it. And this is the tool we use to linearize it. So Taylor's theorem is an indispensable tool for our analysis. Right? So this is Taylor's theorem. So if I rewrite that, this times, you can just do that, delta x plus higher order terms. I say I keep delta x very small. So delta x squared and cubed and all are very small, so nikal do. So kaun sa delta x, how can I choose so that this change is the largest? ये भी एक number देगा. एक नंबर देगा ना ये. तो डेल्टा एक्स का डायरेक्शन कौन सा मैं चुनूं कि ये नंबर सबसे ज्यादा होगा? दो वेक्टर हैं, दो वेक्टर, ये क्या है, उसका नाम क्या, टेक्निकल नाम क्या है इस मल्टीप्लिकेशन का? एक रो वेक्टर, एक कॉलम वेक्टर, आप उसको मल्टीप्लाई कर रहे हो. व्हाट इज द टेक्निकल नेम फॉर दैट? एक वेक्टर ऐसा है, एक वेक्टर ऐसा है, उसका टेक्निकल नाम क्या है? व्हेन वी डू दैट, यू मल्टीप्लाई अ वेक्टर, रो वेक्टर विथ अ कॉलम वेक्टर, व्हाट आर यू डूइंग? You are taking dot product of two vectors. And dot product of two vectors are largest when? Dot product आप ऐसे भी ले सकते हो, ऐसे भी ले सकते हो, ऐसे भी ले सकते हो. कौन सा, what should these two vectors satisfy so that the dot product is largest? 90 degrees, when they are perpendicular to each other. Right? So, when will they be perpendicular to each other? When delta x1, when will they be perpendicular? They will be perpendicular to each other if नहीं गलती बोल दिया, आई एम वेरी सॉरी. परपेंडिकुलर जीरो होगा, आई एम वेरी सॉरी. They are parallel to each other. Dot product perpendicular, it will be zero, like what we did W1 and W2. So when the two vectors are perpendicular, the dot product is zero because it's a projection, right? Yeah, the projection, right? So they have to be aligned, which I have written correctly there. So this is delta x1. If you choose delta x1 to be this, if you choose delta xn to be this, that's the fastest you will change f, because you are doing in the same line. So two vectors aligned will have the highest dot product, cosine theta. Right? So you find out this gradient, you find out the gradient of the whatever you are minimizing, and the next update will be the original point plus this one. That's what it is called, steepest descent. So you put minus there to increase, decrease, and plus to increase. If there's a maximization problem, you put plus. If there's minimization problem, you put minus. Is that making sense? So now we have got a way how to change x1, x2, x3 so that the function f changes the fastest. So this is a proof, if you like, of the steepest descent algorithm. Okay? So I don't know whether you like the proofs or not, but I can't live without proofs. I live when it is beyond my capability. I'm not saying there are many things I have not proved because it is just question of time and resources. But here you can see that the proof was rather very simple. It was Taylor's theorem, you rewrite everything. So that tells us that I take a vector of steepest descent and change my delta x along that direction. So I put alpha there because this is like learning factor eta. You don't go the whole hog. Why? Why don't I go the whole? Alpha is 1 or alpha is 10, so I would go faster. Why would I not choose alpha as 1 or 10 or 100? Because I know the direction is the best direction. Why would I restrict myself? मेरे को यहाँ से दिल्ली जाना, I find the road which is the shortest road. तो मैं फिर क्यों बदलूंगा? क्यों थोड़ा थोड़ा जाकर फिर मैप चेक करूंगा? खत्म. लगाकर GPS और GPS बंद करके ऑटो ड्राइव में दिल्ली पहुंच जाऊंगा. If I know that this is the best way to go to Delhi, then I won't explore. So क्यों हम बार बार explore करते हैं? थोड़ा गए, फिर झंझट करी. थोड़ा गए, फिर झंझट करी. Why? Pardon?
We don't know in which location we have to do the fastest change. That's why.
नहीं, वो तो x0 तो है ना आपके पास. x0 तो है आपके पास. x0 plus delta x0 you have to do. And we know that if delta x0 is in the direction of the steepest descent, you are doing the best you can do. उससे अच्छा आप क्या करोगे? So why do I put alpha as very small number और झंझट करता ही रहता हूं मैं बार बार. Accurate क्यों accuracy चली जाती है? You are right, accurate. Why does the accuracy is lost? Because these are very important points. The accuracy is lost because we are linearizing a non-linear problem. We are linearizing a non-linear problem. So linearization is valid only in a small region. Right? I have got a function like that. So the linearization is always only valid in very close to that, the tangent. The tangent, what we are doing is we are approximating the function by its tangent. When the function is non-linear, tangent is all right when we are near that point, but it goes very far away from the original curve once we keep going down the tangent or up the tangent. So because our problems are non-linear to start with, we have to very carefully choose this alpha. Making sense? So now algorithm घर पे आ गया. You have got a function. You want to minimize or maximize that function. You choose initial values. You find out the gradient, you choose the next value along that gradient, update your x values, and keep going. Right? And when will be maximum reached? How do I know that maximum has been reached? I do this nonsense, but कभी तो रुकना पड़ेगा ना यार.
When our error is within limit.
And you're 100% right, and the slope goes to 0. यहाँ slope 0 चला जाएगा ना. But you are right that in many situations we don't wait till the slope goes to 0 because it could be very close and you fiddle, keep going. You go from here to there. So if you are here, you might go there, then come back, करते रहो तो वो झंझट है बहुत. So you are right that we say if error is less than that, please stop. Pardon? Threshold value आप जो set करें, I can live with this error आप कहें. So that is your choice. That sometimes you can live with large error, sometimes you can't live with large error. So you decide that threshold value and run your algorithm. Making sense? Okay. अब कहाँ जाएं? उई, sorry. मेरे को कई बार लगता है कि how I was allowed to live for so long in this world. किसी ने मेरे को पकड़ के जेल में बंद क्यों नहीं कर दिया? इतनी सब चीजें मैं गलत करता हूँ जिंदगी में. You know Attorney General, right? Attorney General सबको मालूम है लॉ का वो होता है. So one day he called me in Canberra. So Himanshu, अरे मैं कूद गया. मैंने कहा यार you calling me, हमने क्या कर दिया? क्या आपने मेरे को कॉल किया, इसका मतलब मेरी कई गलती पकड़ी गई. No, don't worry. So he said that unfortunately this has been my life. वो उसका last week था for his work. And he wanted me to become a marriage celebrant, so to get people Hindus. So Hindu का तब कोई ना था नहीं ना. So he said, I would like you to do this job because you are so fit to do that. But कहने का मतलब ये है कि he said, whole my life I have suffered. किसी को भी फोन करो वो सोचता है ये पकड़ेगा मेरे. Most people do so many things wrong. मेरे को ये लगता है मैं इतनी सारी चीजें गलत करता हूँ. How did I survive for so long? Anyway, so this you can have a look. This is function of one variable, which is quite simple. So this is the algorithm. So ये है नम का, but अपन इसको ढंग से करते हैं. Okay. So now थोड़ा कर लेते हैं ये, फिर बंद करेंगे. I have got points x here, and what could be that vector y d? D का क्या मतलब है? D अपन किस लिए काम में लेते हैं? Desired. So मेरे पास ये x है और मेरे को ये yd desired है. So इतने पे तो है, पर कोई नया x आएगा तो so I want to design a classifier. ये classifier based on this information, so that the next time a new point comes, I can tell whether it belongs to this group or that group. ठीक है? Is the problem clear? I know the truth value. Yes, आपने कहा था, किसने कहा था कि truth value you need? Okay, anyway, somebody said that you need truth value to train it. So now here we come to an algorithm where truth value is needed. Right? So we have this story. So this is the algorithm. Previously यहाँ क्या था? No yd. Now it is yd minus y. Right? So this is a slightly different algorithm than we had before, but the steps are the same. We modify W1, we modify W2, we modify B, but with the different equations, ठीक है? The other one had yd, we did not give, we gave only y. Here YD, we know the truth value or the desired value of the classifier at these points, and this is the algorithm which is called Widrow-Hopf's learning algorithm. Right? Widrow is a famous man. विड्रो की किताब आपको कभी पढ़नी चाहिए. It is so simple. And you would wonder that how these things became so extraordinary. जो विड्रो का एल्गोरिथम है, that is the heart of everything we do now in machine learning. और उसके पेपर पढ़ो आप. Anybody does communication? So array antennas, you have heard about array antennas, right? Array antennas. So Widrow का original algorithm था कि array antennas, where do they point? Right? So he could change the delays in the array and point. So now, otherwise what if you have to point your signal to that, you have to move your antenna, right? या इधर उधर. तो उसका array ऐसा था कि by changing the delays in that line, he could point any direction. So that was his initially famous work, and the same, exactly the same has been used here. So कहने का मतलब ये है कि जो ये महान लोग होते हैं, they think very simply, it's very deceptive. आप पढ़ेंगे तो कहेंगे यार ये क्या है? This man is so famous, this algorithm is so famous, it's very deceptive, but it has got far-reaching consequences. So Widrow का काफी वो है, उसकी किताब में एकदम crystal clear. You know, you should read his books. Okay, so this is the algorithm. So now what is the theory behind this algorithm? ये algorithm समझ आ गया ना, इसमें तो कोई झंझट है नहीं. So now we want to know the theory behind this algorithm. क्या लिखा है मैंने? The same thing as we had before, right? उसमें कोई वो change नहीं है the process, right? What we had before. Only thing the equation is different. Now why is that? So that's the thing I get. So what's the data मैंने दिया? हाँ, वो data जो ऊपर दिया था. You see the data here. So 3 में 1 था, 1 पे 0 था, the true value, right? So we wanted 3 points to be classified in one group, 1 point to be classified in another group. I ran this algorithm, and that's what you get, right? So these are vectors to be classified or points to be classified. So when you run through the Widrow algorithm, so this is called supervised classifier because you have got the output value YD is given to you. ठीक है? So now, okay, ये आपके लिए चलो. ये मेरे को लग रहा था कि मेरे रेस्ट करने का टाइम आया है. करो आप ये. You know YD is a number. And what is Y? We had whatever Y was before the same Y. कोई अंतर नहीं है. But that Y you have to write in terms of W1, W2 and all that. और मैं क्या इसमें? Do you need? Do you need this information? कोई बात नहीं, you do it that way. If you need that information, you will supply. If I have written it here, then there must be some reason why I wrote it. Okay? मैं जा रहा हूँ मैस में अभी डाइनिंग हॉल ये 2-3 बजे तक खाना रखना और सब 2-3 बजे तक खाना खाने आएंगे. वो जोक है ना, उसमें प्रोग्राम में आना इज फ्री. यार ये तो बहुत अच्छा, इतना जोरदार प्रोग्राम इसने, इस आना फ्री. तो जैसे ही सब अंदर घुसे उसने दरवाजे बंद कर दिए कि मैंने कभी नहीं कहा कि निकलना इज फ्री. तो वैसे आप आए दैट वाज फ्री, बट आप जाओगे तो ये देकर जाना पड़ेगा. आप लिखिए, you got 4 points, right? And you know how to take derivative of this. So y का आपको मालूम है, y is w1 y is w1 x1 plus w2 x2 plus b. या आपको मालूम है y ये है, आपको पॉइंट्स मालूम है, राइट? 4 पॉइंट्स दैट यू हैव, ये लिख लें. Quickly write these 4 points. You don't need to write the points, you need to give a general algorithm. आपको लिखना है, लिख लें points here. In this you can assume that you know yd is a number, right? And y is this thing here. So you have to, okay, good. So we can do it again. So what are the variables? ये y ये है. So we have to take derivative with respect to which variables? आपका गोल्ड मेडल गया. सर यहाँ हैं, रिकमेंड कर देंगे. नहीं, I'm just joking. किस में? x1, x2 are the points I give you. वो थोड़ी बदल सकते हैं. I need to change something to minimize. Right? x1, x2 the point दिए हुए हैं आपको. वो कैसे बदलेंगे? That are given data. You can't change it. So what can you change to minimize the error? Bias, yeah, or? Yeah? Yeah? Weights W1 and W2. So you have to change all these 3 things to minimize the error. So आप ये लिखें, function लिखें, yd minus y की वैल्यू आपको मालूम है, then you take the derivative. सीधा काम. इन गुजरात देश से सीधा भाड़ा और सिद्धपुर की यात्रा. सीधा काम है एकदम. सॉरी, आप पे ये फ़ोन के कमेंट करके और मैं खुद लग गया. Sorry about that. मेरे को I have to tell one friend is coming to meet, so I have to tell that I am almost done. Sorry about that. एंट्री मेन गेट से ही है ना यहाँ? एंट्री मेन गेट से ही है.
गेट नंबर
Okay, so I'll tell him, let us know which gate you are at, right? He's only 2 kilometers. No, he's just 2 kilometers away, somewhere. तो मैंने कहा 1 बजे बाद. तो वो उसने कहा मेरे घर चलो. So I'll go to his house for lunch. वो हमारे स्कूल का साथी हो. Yeah. So I'll come back. He will come and pick me. हाँ, इसीलिए. जहाँ भी है, once he comes, he can let which gate he is it and you can tell how to come. Right? At the gate. आप लोग कब भाग जाएंगे? यू विल बी देयर व्हेन आई कम बैक? कि गायब रहेंगे? ओके कह नहीं सकते देखो.
Computer lab is open for this.
So श्रीनिवास जी सॉरी मकरन जी सॉरी. जब सबको ईमेल कर दो वो फोल्डर, so you can use the MATLAB scripts in there to do all these things in the. So the slides में वो भी है. All the tutorials and everything is there, so you can start from the first. The programs are there, just start playing with it. Then you'll get some sense of it.
I think you have mailed to me. You already mailed me. Right?
पढ़ना?
You already mailed me.
हाँ वो इनके पास है, श्रीनिवास जी के पास है. वो तो फर्स्ट, वो तो डे 1 का स्लाइड है. अपन डे 3 में अभी डे 1 में ही चल रहे हैं.
It is there.
नहीं अभी नहीं, मैंने कहा आओ तो फोन कर लेंगे. तो we'll go to the guest house if you are going. I will come with you guys and then I'll wait for him there. या डिपेंड. सबने एक्सप्रेशन एक बार तो लिख लो आप. एवरीबडी यू राइट इट एटलीस्ट वंस. कोई इतना मुश्किल नहीं है. सर कल अपन ऐसा कर सकते हैं कि आई गॉट 2 लेक्चर्स राइट. तो लेट्स स्प्रेड इट. सुबह फिर आफ्टर लंच. सो जो आफ्टर लंच वाला है वो बीच में, क्योंकि आई थिंक आई गेट टायर्ड नाउ.
नहीं, that you're not continuous.
Yeah, after lunch there is no lecture tomorrow.
तो नो नॉट, मेरा जो सेकंड लेक्चर है वो आफ्टर लंच कर दो.
After lunch.
तो आई विल हैव अ ब्रेक
So,
He wants break. Why not?
अगर पॉसिबल है.
नहीं possible है, very possible.
that is another issue.
अच्छा नहीं उनका दो फिर talking about 3 times.
We want to shift it in afternoon. We
हाँ
have to shift that lecture in the morning.
ठीक है ऐसा कर लेंगे.
ओके इफ यू कांट डू इट सॉरी.
And today sir, when we should pick up you after lunch?
वो छोड़ जाएगा.
अच्छा वहीं छोड़ देंगे.
कहाँ यहाँ मैं ले आऊँगा कल यहाँ छोड़ देंगे.
Or in front of electrical department.
हाँ या कम.
I send you this location.
अब तो फोन इतने हैं यार, सबके पास फोन है. अब क्या. यस आपने किया. वेरी गुड. गुड. या दैट्स गुड. सो आपने माइनस साइन क्यों लगाया? स्टीपेड डिसेंट का आप लगाया इसलिए माइनस है. कोई बात नहीं. गुड. और जस्ट सी इफ दैट मैचेस द एल्गोरिथम व्हिच इज देयर इन दैट. So writing derivative is not so hard if you can show that this, based on the derivative, that this is the steepest descent algorithm. That this is written according to the steepest descent algorithm. Right? आपने जो काम कर लिया वो ठीक है. You have done all the hard work. Now you have to just मैडम कुछ आगे बढ़ रहे हैं. We don't look at the numbers, we just look at the abstract one. Write yd minus y whole square, and the variables with respect to which you want to get the derivative is w1, w2 and b. Right? So yd minus y square. So we are just dealing with symbols here, we are not putting any numbers yet. We are trying to see if these three equations are according to the steepest descent algorithm, these three equations. अगर हैं तो अपना काम हो गया. अगर नहीं है तो विड्रो साहब ने कहीं गलती करी है. Okay, if you want to go because आप भी थके होंगे. But I mean, if you want to spend some time in the lab after lunch, most welcome.
Session will continue with this tutorial only.
Tutorial, yeah. थोड़ा करेंगे, then I have got hospital capacity thing also. So once, I mean, back propagation algorithm we have to do before we take anything. So after this is back propagation. हाँ बोले आप कहाँ? हेलो, हाँ बोले कहाँ? एक कोई बात कर लो हमारे कोलीग से.
Weekend is ready, but you operate a weekend or participate.
After the session 2 o'clock.
Okay? Good.
So 2 to 3:30. So 3:30 to 3:45.
Okay, you join us for tea break that time.